Oh, let's talk about the effects of a price increase. This would be our last video. It's going to be short compared to the other two. I think it'll be fine. There's not a lot of examples that we can do in this section, so we're just going to kind of keep trucking through. So let's talk about income effects and substitution effects. So think about this for a second. Can all goods be inferior goods? No, right? It wouldn't make sense because it would imply that the consumer would buy less of both goods when income rises. So as our demand shifts out, we can't have both goods shift down, right? And so not everything can be the inferior goods, but that is going to be kind of something that we could consider when we're thinking about income effects and substitution effects. Is that holding tastes, other prices, and income constant, an increase in the price of a good has two effects on an individual's demand. For normal goods, a decrease in price, I mean, an increase in price, um, causes a substitution effect. Holding utility constant, the consumer is going to substitute away from the expensive good and buy more of the other good, which would be relatively cheaper. But the income effect is holding prices constant, the consumer's purchasing power is reduced, and so she's going to buy less of both goods. And so now there's this thing called the total price effect, which comes from the substitution effect and the income effect. A substitution effect causes a movement along the indifference curve, and the income effect causes a shift of the indifference curve because we have less purchasing power. So let's think about the effect of a price increase for a normal good. So suppose that we have this utility function. U is equal to Q1 raised to the 0.4, Q2 raised to the 0.6, subject to 30 equals 0.5 Q1 times 1 Q2. So let's draw the budget line with our appropriate intercepts. Right, let me just make sure. So for a normal good, let's draw this first. We're gonna have Q1, Q2. If we weren't gonna buy any of Q2, we would be able to buy 60 Q1s. If we were only going to buy Q2s, we would have 30 Q2s. So then now let's calculate this optimal bundle, right? So if we wanted to take MRS, which should equal minus 0.4 Q1 to the 0.6, Q2, 0.6, 0.6, Q1, 0.4, Q2, minus 0.4. We're going to get minus 2/3, Q2 over Q1. Our MRT should be minus 0.5 over 1, which should equal minus 1/2. So we now would get our optimal, setting these equal to each other. Then we would get Q2 should equal 3Q1 and 30 should equal 3.5 Q1. We're going to get somewhere in here. It's going to be something like 8.5, something like this. Oops, I think I made a mistake somewhere along these lines. What if we just instead, I mean, this would be fine, I think. You'd be able to find it this way. That would be the tangency way. This would be correct. Or we should just do the regular one, right? Let's use the formula that we came up with earlier. It's not going to be 8.5. This is actually a lot easier question. I was looking at the wrong question. So Q1 star, given a Cobb-Douglas function over the price, which should be 24, and Q2 star should be 18. which would be 0.630 over 1, should be 18. That was where my 8 was coming from. So we've got something like this. I'm going to blow this up. It's not going to let me just blow this up. That's crazy. What will if I do it like that? So now this would be at E1, at equilibrium 1. So now suppose that P1 shifts from 50 cents to $1. So it is going to cause a reduction this way. So then Q1 star is now 0.430 over 1 or 12. And so we've got something like that. This change here is 12. So this total effect of an increase in P1 is minus 12. Okay? So now we should be able to deconstruct both of these into substitution effects and income effects. So again, suppose we have the exact same thing, but now our consumer is compensated for the price increase. So we're going to get a little bit of extra so that we can maintain a constant utility, right? So if we come back here, we had an indifference curve. We had two indifference curves that we were dealing with, right? So if we come back, let's copy this, paste this back down here. Now we're given a little bit extra. This budget line should stay the same. So now we've shifted this from our hypothetical budget line 1 to our hypothetical budget line 2. And when we're shifting, it's going to be parallel to our original one. Our new optimal bundle is going to be up here. And so instead of being at 24, this is going to drop to be 16. Okay, so let's just suppose that it's going to be dropped for 16. So the hypothetical compensation, we're given an extra $10. So our Y shifts from 30 to 40. And so we're going to be shifting from again, these budget lines are parallel. We're going to be moving from this equilibrium. So this was E1, this was E2. Let's call this E3 for now. We're going to be shifting here, and this is going to only cause a substitution effect of minus 8. Right? And you would be able to find the optimal values again. You could use everything that we had done before. But now we've got this income effect as well. And so imagine her income has to lower while holding everything constant. Um, this is going to force everything to jump the last four down, right? So holding prices constant now, the change from Q1 from E star to E2. So essentially, we are moving, oops. Essentially, we are moving first from E1 to E3 and then E3 to E2 instead of just straight to E2 like we were doing beforehand. So again, remember our income has to come back down. So 40 is going to decrease back to 30. We're going to hold prices constant. from E3, and our income effect is going to cause this to decline by 4. And so we're going to get this last little bit here, and we should have everything, right? So if we wanted to think about this a little bit more, we could think about the income effect decomposition. Sorry, this is a much cleaner way to draw what I was just drawing, right? So originally we started here at E1. We had this increase in this price that causes this substitution effect to slide this way. I mean, this price effect to slide this way. So now we are at this line, and we had pivoted from our original line. And when we pivot from that original line to here, we move from E2 to calculate this total effect. But remember, we have these two effects that are competing. So if we had the substitution effect, so we're going to be here, we could pivot back out if we were given more money to hold the utility constant from our original. So remember, when we shift from E star in the substitution effect, how much extra money would we have to get to hold these budget lines parallel, but to stay on the same level of utility? So rather than going straight from E1 to E2, we now move from E1 to E star. And so we're going to be back up here at E star. And then finally, we can't have that money forever. So we're going to have to decrease back down. And so holding our prices constant, then we are going to move back down to E2 for our income effect. And we're going to be able to see that entirely. So this would be our effect decomposition for two goods that may or may not be perfect substitutes. If we wanted to look at something for perfect complements, we would be able to look at something similar. We could remember our indifference curves for perfect complements are very simple. They're going to be right angles. We don't want more than one good here, right? If we had an original budget line that allowed us to be at this corner like this, and then we had a new budget line that shifted us to here. This effect, like let's just call this 1 and let's just call this 2 because this was E1, this was E2. This would be our total effect. There is no substitution. So if we wanted to maintain this line to keep things parallel and our utility constant, this entire effect is going to be the income effect. And similarly, for perfect substitutes, it would all be a substitution effect. And the last thing that we have is this thing called an inferior Giffen good. So a Giffen good is a low-income, non-luxury product, but as price rises, quantity demanded also rises. So we have an upward sloping demand curve. We're not really going to get much into that, but if you need to know that, notice that the total effect, so the substitution effect causes you to pivot one way, but the income effect causes you to pivot the other way. And so your total effect is going to be a lot smaller, but because you have two effects pulling in opposite directions. So it's just what one's going to win when we have something like that. But yeah, that is chapter 4 demand. So we should be able to keep going with the next chapter. This is also the end of midterm 1 content. So for Thursday and Friday, if you're watching this on time, please take a look. Email me if you need help with the midterm or want to review some other things. Take a look at those homeworks. Take a look at those quizzes. Everything should be good for week 1 now. I'm going to try to get all of these lectures recorded. I should have at least through week 2. So if you guys are flying through these, and I just might have one lecture that I might post on Monday. But for the most part, everything should be good to go. You guys should be good to get through at least the first week of courses. If you need anything, please let me know. And yeah, feel free to email me. I'm always down to talk, chat, set up a Zoom, do something. We should be good to go. So yeah, good luck. Let me know if you guys need anything.